Hello everyone. On this video we will be looking at U-substitution for trig functions, log functions, and exponential functions. Alright, so to do that you're going to have to remember, just like you did with your derivatives, you're going to have to remember your integral formulas. Okay, so the integral of sine u with respect to u is negative cosine u. The integral of cosine u is sine u. The integral of tangent u is negative natural log of the absolute value of cosine u plus c. The integral of cotangent is natural log of sine of u, positive sine of u, or absolute value of sine of u. The integral of secant is natural log of the absolute value of secant u plus tangent u plus c. The cosecant integral is the negative natural log of cosecant plus tangent of u, the absolute value of that plus c. The integral of secant squared is tangent. The integral of cosecant squared u du is negative cotangent of u plus c. The integral of du over u, or 1 over u times du, is natural log of the absolute value of u plus c. The integral of e to the power of u du is e to the power of u plus c. The integral of the base of a to the power of u du, so if you had like 2 to the power of 7x or something like that, then that will be a to the u divided by 1 over natural log of whatever your a value is plus c. And if you have the integral of a log base a of u du, then that will be just u natural log of u minus 1 divided by natural log of a. Okay, so it does help if you memorize these because they do come in quite handy when you move on to Calc 2 and further down the line. Alright, so if you are still writing these, and I'm pretty sure you're probably still writing them, by all means feel free to press pause, but we're going to go ahead and jump to our first example. Alright, so let's say you have, for example, you have the integral of negative 11 times t to the 7th power cosine of t to the 8th with respect to t. And you want to find that integral. Alright, so to solve this, we're going to let our u equal what's inside of our cosine parentheses. So we'll let u equal t to the 8th power, which means our differential du is equal to 8t to the 7th dt. And of course, if we divide both sides by 8, we end up with du over 8 equals 2 to the 7th with respect to t. Okay, so really we're going to use this one, and we are going to use this one. Alright, so just for convenience purposes, we're going to switch those two around. We're going to bring our negative 11 on the outside because we really don't need it when we're doing all of our calculating. So I'm going to go ahead and rewrite that. So bring the negative 11 outside. The integral of cosine t to the 8th times t to the 7th with respect to t. Okay, so you can see here, since our t to the 8th is our u, this is just cosine of u. And this part, our t to the 7th with respect to t, that's just our du over 8. Okay, so we're going to go ahead and rewrite it just with our u terms. So negative 11 times the integral of cosine of u du over 8. Well, times du over 8. So once again, we can get that 8 in the denominator and bring that to the outside. So negative 11 over 8 times the integral of cosine of u du. Okay, so we already know the integral of cosine of u is sine of u. So we have negative 11 over 8, and this just becomes sine of u plus c. Okay, and actually you can make that C1 if you want to. You don't have to, and I'll show you why we're doing that, but it's really kind of an unnecessary step. But I'll show you why we're making that C number 1. It's because when you distribute this negative 11 over 8, that's going to give you negative 11 over 8. And of course, we're going to replace our u with t to the 8. So sine t to the 8 plus, you can say a negative 11 over 8 times c sub 1. A constant times a constant is still a constant. So really, you didn't have to do that step. I just wanted to explain that you could. Okay, so really that just becomes negative 11 over 8 sine of t to the 8th plus c. And again, you could have just made that plus c from the very beginning, and you would have been okay. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so let's say, for example, you have the integral of 17, and make that 1 look more like a 1. 17 cosine 4 of t sine of t with respect to t. Okay, so this one's just a little bit different. All right, so to do a problem like this where you have cosine or sine raised to the 2nd, 3rd, 4th power, 20th power, it doesn't really matter. If it's cosine or sine raised to any of these powers, you want to remember that you can rewrite it cosine 4th of t. You can rewrite that as cosine of t to the 4th power. Okay, that makes it a lot easier to work with. All right, so what if we let our u equal cosine of t? Okay, so that means our differential of du is equal to negative sine of t with respect to t. And if we divide both sides by negative 1, that gives us negative du equals sine of t with respect to t. And again, you can have that negative here. You can put a negative 1 times du. Doesn't matter. Whichever one you're comfortable with. And we're going to be using both of those. All right, so we're going to go ahead and just bring our 17 right on the outside because we don't need our constant right now. So we have 17 times the integral. Now remember, we rewrote our cosine to the 4th. So that's just cosine of t to the 4th power times sine of t with respect to t. All right, so this is our u. So this just becomes u to the 4th power. And this, our sine of t with respect to t, is just negative du. So we're going to go ahead and just rewrite it just with all u's. So you have 17 times the integral of u to the 4th times negative du, or you can put -1. And again, that negative, we're just going to bring that to the outside. Same way we would any constant. So you have -17 times the integral of u to the 4th du. And we just integrate with respect to u. So that's -17. So that's u to the 5th over 5, because u to the 4 plus 1 divided by 4 plus 1. Plus c, and remember you can do the c1 if you want to. You can just make it plus c and leave it like that. Okay, so once you do that, you can factor out that 5. So we have -17 over 5 times u to the 5th plus c. All right, so last but not least, we replace our u. Okay, so that gives us -17 over 5 cosine to the 5th of t plus c. All right. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so now we're going to solve a definite integral. Okay, so what is the value of the integral from pi over 2 to pi of 3 cosine of t sine to the 5th of t with respect to t? And it should be a question mark there. All right, so just like before, you want to remember that you can rewrite your sine to the 5th as sine of t to the 5th power. All right. So in this case, we're going to let our u equal sine of t. Okay, so let u equal sine of t. So our derivative of u, our du, is going to equal cosine of t with respect to t. And we don't have any coefficients to factor out, so there's no 8 cosine of t. We'd have to divide both sides, so we're good just like that. All right, so once again, we're just going to rewrite this, and just for convenience purposes, we're going to switch those two around and bring our 3 on the outside. Okay, so we have 3 times the integral from pi over 2 to pi. We're going to put sine of t to the 5th power times cosine of t with respect to t. Okay, so once again, since our sine of t is u, this is just u to the 5th power. And this is just our du, which we have right here. So if we rewrite it just using the u terms, we have 3 times the integral from pi over 2 to pi of u to the 5th du. That's going to be u to the 5 plus 1 over 5 plus 1, so that's 3 times u to the 6th over 6 and that's from pi over 2 to pi. Okay, so if we go ahead and get that 6 and factor it out, we have 3 over 6 times u. Oh, we don't have the plus c, of course, because we have a definite integral, so that's u to the 6 from pi over 2 to pi. Okay, so what we could do is we could find our u to the pi and u to the pi over 2 just to have those u values, or we can go ahead and just change this back in terms of t. So I'm just going to go ahead and use the method of replacing the u. Okay. And again, there is another method where you can take u of pi and u of pi over 2 and solve it that way. You don't have to plug that in if you don't want to, but this is just the method that I'm choosing to do on this one. Okay, so that would be 3 over 6 is just 1/2. So you have 1/2 sine of t to the 6th power. And that's from pi over 2 to pi. So now we go ahead and use the fundamental theorem. So we have our 1/2. So we plug in our pi. So that's sine of pi to the 6th power minus sine of pi over 2 to the 6th power. Okay, so we know sine of pi is just 0. So we have 0 to the 6th power, that's just 0. Okay, sine of pi over 2 is 1. 1 to the 6th power is just 1. So we have 1/2 times, you have that minus 1, so that's still -1, which is -1/2. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so what if you have the integral from pi over 3 to 4 pi over 3 of -4 cosine of t sine squared of t with respect to t. So let me clean up that pi a little bit. This should be 4 pi over 3. All right. So what I want you to do is I want you to go ahead and press pause and try to solve this one on your own. All right, so I'm assuming you've pressed pause and worked this out. So let's go ahead and verify your answer. Okay, so once again, you want to remember that your sine squared of t, you can rewrite that as sine of t squared. Okay, so we're going to let u equal sine of t, which means our du is going to equal cosine of t with respect to t. All right, so just like before, I'm going to go ahead and factor out that -4 to the outside. And just for convenience purposes, I'm going to switch those two around. All right, so we have -4 times the integral from pi over 3 to 4 pi over 3 of sine of t squared times cosine of t with respect to t. All right, so here, of course, we have our u, so that just gives us u squared. And our cosine t with respect to t, that's our du. All right, so let's go ahead and rewrite it just using the u terms. So -4 from pi over 3 to 4 pi over 3 of u squared du. All right. So, of course, that's just going to be -4 times u to the 2 plus 1 over 2 plus 1. So u to the third over 3. And that's from pi over 3 to 4 pi over 3. So you can go ahead and factor out that 3. You don't really need it right there. So you have -4 over 3 times u to the third pi over 3 to 4 pi over 3. All right, so we're going to go ahead and just replace our u. So that's going to give us -4 over 3, and our u, sine of t. So that's sine of t to the third power. And again, that's from pi over 3 to 4 pi over 3. Okay, so now we go ahead and use our fundamental theorem. Okay, so I'm just going to move this equal sign over a little bit. So you have -4 over 3. You plug in our 4 pi over 3. So that's sine of 4 pi over 3 to the third power. Minus, now we plug in our pi over 3. Sine of pi over 3 to the third power. All right, so we have -4 over 3. Sine 4 pi over 3 is just negative square root of 3 over 2. So you have negative square root of 3 over 2 to the third power. Minus sine of pi over 3 is just positive square root of 3 over 2. So you have square root of 3 over 2 to the third power. All right, so if we go ahead and multiply that to itself 3 times, we will end up with -4 over 3 times 3 square root of 3, well, -3 square root of 3, because negative multiplied to itself 3 times is still negative, over 8, minus 3 square root of 3 over 8. Close that up. Okay, so that's going to equal -4 over 3 times -6 square root of 3 over 8. All right, so we can go ahead and simplify this. 4 goes into 4 once. 4 goes into 8 twice. 3 goes into 3 once. 3 goes into 6 twice. So that gives us -2 over 2. And a negative divided by negative, well, negative times negative is a positive. And 2 divided by 2 is 1. So that just gives us square root of 3 as our final answer. All right. So if you're still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so let's say for this one, we have the integral of 11 log of base 14 of t with respect to t. Okay, now for this one, remember that the integral of log base a of u with respect to u is just u times the natural log, the absolute value of u, minus 1 divided by your natural log of a. All right, so we have our formula. So that means if we go ahead and just get that 11 and factor it out, we have 11 times the integral of log base 14 t with respect to t. Okay, now in this case, our u is just equal to t. And our du is just equal to dt, or 1 dt. Okay, so we can see here that our a is equal to 14. Our u is equal to t, and our du is just equal to dt. Okay, so we can go ahead and get all of those and plug them into our formula here. So this is going to be 11 times, we have our u, which is just t, so that's t times natural log of the absolute value of u, so that's just the natural log of the absolute value of t, minus 1 divided by the natural log of a, which is just the natural log of 14, plus c. But since the natural log of 14 is a constant, if you wanted to, you can just factor that out. So you have 11 over the natural log of 14, or you can bring the t out too if you want to, just to make it a little bit neater. So you have the natural value, the natural log of the absolute value of t, minus 1, sorry about that, minus 1, plus c. Okay, so either way you write the answer, it would have been correct. I just wrote it this way just to kind of make it a little bit neater. All right, but it's not mandatory to do that. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so what if you have the integral of 9 over t minus 5 with respect to t? Okay, so I know you're probably thinking, okay, this isn't a log integral, this is not an exponential, this isn't a trig integral, how does this fit? Okay, well, with this, you can try any other method that we've learned so far, and it would not work. So for here, our goal is the integral of du over u equals natural log of the absolute value of u plus c. And with these, it takes a little bit of practice to be able to immediately see this and think, okay, u du. Okay? But we're going to go ahead and factor that 9 out to the front. So you have 9 times the integral of 1 over t minus 5 with respect to t. Okay, so what if we let our u equal t minus 5? Okay, that means our du is just going to be 1 dt, or just dt. All right, so we're just going to get that dt and move that up to the top. Like I said, you don't have to. It's just for to help visualize it. So you have 9 times the integral of dt over t minus 5. Okay, so we see here that that's our u, and our dt is our du. Okay, so really that gives us 9 times the integral of du over u, which is the natural log of u, the absolute value of u, plus c. That's 9 times the natural log of the absolute value of u plus c. Alright, so last but not least, we replace our u. Alright, so once we do that, we end up with 9 times the natural log of t minus 5 plus c as our final answer. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so what if we have the integral of 4t to the 4th times e to the 6th t to the 5th with respect to t. Alright, so we have an exponential function. So for this one, our goal is to have the integral of e to the u du equals e to the u plus c. Let me clean up that e a little bit. E to the u, there we go. Alright, so in this case, we're going to let me write down that we're solving it here. We're going to let u equal 6t to the 5th. Excuse me. That means our derivative of u with respect to t, we're going to bring down that 5, so our 6 times 5 is 30. So we have 30, and subtract 1, t to the 4th with respect to t. Okay, so we have our u, and we have, oh, not really, because we're going to go ahead and get rid of that 30 right there, just to, and again, you can do it without getting rid of the 30, but to me, it just looks better, a little easier. Divide both sides by 30, we have du over 30 equals t to the 4th with respect to t. Now we go ahead and circle that. Alright, so we're going to go ahead and rewrite this. Again, I'm going to factor out that 4 and just switch those up. Like I said, just for visual purposes. You don't have to. But it just makes it a little easier and a little less likely to make a mistake. Okay, so we have 4 times the integral of e to the 6t to the 5th times t to the 4th with respect to t. Okay, so again, this part, our 6t to the 5th is u, so this is just e to the u. And our t to the 4th with respect to t, that's our du over 30. Okay, so we're going to go ahead and just rewrite this just with terms of u. Okay, so you have 4 times the integral of e to the u times du over 30. And just like before, we're going to go ahead and get that 30 and factor it out to the front. So that's 4 over 30 times the integral of e to the u du. Okay, so the integral of e to the u du, 4 over 30 simplifies to 2 over 15. And that's just e to the u plus c. Okay, just if we went ahead and integrated just that. So now finally we replace our u, and that will equal 2 over 15 e to the 6t to the 5th plus c as your final answer. All right, so if you're still writing, feel free to press pause, but we're going to go ahead and move on to our next example. I want you to see as many examples as possible so you can kind of get a feel to how to approach these. All right, so let's go ahead and move this out the way. Oops. There we go. All right, so let's say for this example, if we have the integral of 30t plus 54t to the third divided by 10t squared plus 9t to the fourth with respect to t. Okay. Now this one is just like the one we did where it was the integral of 9 over t minus 5, where it doesn't look like it's a problem that would be solved using logs or exponentials or anything like that, but it actually is. And again, it takes practice to be able to just look at it and immediately know where to go. Because once you see it a few times, you'll get kind of a sixth sense for it and you'll know exactly where to go. So for this one, again, our goal is the integral of du over u, which is the natural log of the absolute value of u plus c. Okay, so what if we let our u equal 10t squared plus 9t to the fourth? That means our du is going to equal 20t squared plus 36t to the third with respect to t. Okay, so I know what you're thinking. You're like, wait a minute, this does not match that, so how is that going to be our du? Well, what we do is we're going to get that and we're going to make it equal our du. So what we want this to do for our t squared, oh, not t squared, should not have put t squared there, should be t. For our 20t, we want to make this 30t, so it'll match that. And this term, we want to make this 54t to the third, so it matches that. All right, so how do we do that? Well, we do that right on the side. We want 20t to equal 30. Okay, so if we divide both sides by 20, we have t equals 30 over 20, which is 3 over 2. Same thing here. If we want 36t to equal 54, we divide both sides by 36, we have t equals 54 over 36, which is actually 3 over 2, once you simplify it. All right, so if we multiply both of these by 3 over 2, we will end up with 30t and 54t to the third. Okay, so how does that help us? Well, that helps us because I'm going to put a little bit of space here. If we have 20t plus 36t to the third, and we multiply it by 3 over 2, of course with respect to t, then that means we just multiply both sides by 3 over 2. So you have 3 over 2 du. Okay, again, if you distribute this out, you have 60 over 2, which is 30. And you distribute this out, you'll end up with 54t to the third. So it works out. You just have to do the same thing to both sides. Okay, so that means our 3 over 2 du is equal to 30t plus 54t to the third with respect to t. Okay, so those are the two we are going to be using. And again, all we did here was just distribute that out. All right, so now that we have all of our u's and du's ready, we have the integral of 30t plus 54t to the third. And again, that dt, we're just going to move that right up top. Again, you don't have to. It's just for visualization purposes. Okay, over 10t squared plus 9t to the fourth, which really, remember, down here, that's our u. So that's the integral of our u. Remember, that's our u. And up here, that's our 3 over 2 du. Because we have that. That's our 3 over 2 du. All right, so if we go ahead and factor out that 3 over 2, it gives us 3 over 2 times the integral of du over u. All right, so what's the integral of du over u? Move that up. That's just 3 over 2 times the natural log of the absolute value of u plus c. Okay, so we go ahead and we replace our u, and that will give us a final answer of 3 over 2 times the natural log, and our u is 10t squared plus 9t to the fourth. Okay, so 10t squared plus 9t to the fourth plus c. Okay, now you might see, if you use an app or something like that, you might see where they just have, instead of the absolute value, they just have parentheses. You'll see the absolute value replaced with parentheses if there's no real number that you can plug in for t that will make this negative. Okay, so no matter what number you plug in for t, this will always be positive. So you could see, instead of the absolute values, just a set of parentheses. So again, the only time you will see parentheses here is when this number is just impossible for that number to be negative using real numbers. Of course, if you use complex numbers, changes things. But we're dealing just in real numbers, and there's no real number that can make this negative. But we just kept the absolute value just because. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our last example. All right, so let's say, for example, you have the integral of 2 cosine of x over negative 2 plus 6 sine of x with respect to x. Okay, and we want our exact answer. All right, so what I want you to do is go ahead and press pause and try to solve this one on your own. Okay, so use a little hint, use the previous example as kind of a guide. All right, so I'm assuming you've pressed pause and you've worked this one out and you got this one out the way. So let's go ahead and verify your answer. Okay, so for this one, what if we let u equal -2 plus 6 sine of x? Okay, that means your du is going to equal 6. The derivative of sine is cosine. Cosine of x with respect to x. And we go ahead and divide both sides by 6. And that gives us du over 6 is equal to cosine of x dx. Oh, clean up that x a little. There we go. Go ahead and clean up both of those. Okay. So now we have those marked off because we're going to use them both. So what we're going to do is we're going to get that 2 in the numerator and just bring that out to the front. We don't really need it. Okay. So we have 2 times the integral of cosine of x. And that dx, I'm going to go ahead and bring that up top because dx is the same as saying dx over 1. And you can just bring it over. Dx over -2 plus 6 sine of x. Okay, so we know that that's our u. And this is our du over 6. So we're going to go ahead and rewrite it. So we have 2 times the integral. Remember, this is our du over 6. Du over 6 divided by your u. Okay, so this is just like saying du times 1 over 6. So we can go ahead and get that 1 over 6 rather, and factor it out. So we have 2 times 1 over 6 is just 2 over 6 times the integral of du over u. Okay, so if we go ahead and simplify that, 2 over 6 is just 1/3. You have 1/3. The integral of du over u is natural log of the absolute value of u plus c. Okay, so from there, we go ahead and we replace our u. And that will give us 1/3 natural log of -2 plus 6 sine of x plus c. Now with this one, we don't have the option of getting rid of the absolute value. Because if you plug in x equals 0, sine of 0 is 0, so then you will end up with a -2. So we can't have a negative natural log, so we have to leave the absolute value up for this one. We don't have the option of replacing it with parentheses because it is possible for that value to be negative. All right. So hopefully this made sense after all the examples that we've done, and I will see you on the next video.